Hello, everybody. Welcome to Proctor, Managing A/B Tests and More. In previous Tech Talks, we've discussed a little bit about how Indeed thinks about A/B testing and a lot about A/B tests we run. In this talk, we're going to talk about Proctor, which is our framework for managing A/B tests. My name is Tom Bergman. I'm Product Manager of Aggregation here at Indeed. I joined Indeed about 4 years ago in the international team and then moved to Search Quality. And Matt Schemmel is also going to be talking. He's a software engineer on the resume team. And we help people get jobs. If you've been to any of our tech talks, you've heard us say this a number of times. This is our motto. This is our key statement. And this is what we think about whenever we're going to add a new feature or do a test on our site. We want to ask, is this going to make it easier for people to find jobs? Is this going to make it better experience for people who are looking for jobs? What's best for the job seeker? That's the real question we are always asking. And the way we figure this out is we test and we measure everything. When we say test and measure everything, we don't just mean all the metrics. We also mean every feature, every change across every product. Before we go in, I just want to give a little bit of definition for A/B testing, crib from Wikipedia. We have, so A/B testing is an experimental methodology comparing at least two variants, a control group A and a test group B in a controlled environment. And to give you kind of an example of this, before we get to that, a couple of key points. Testing control groups should be unbiased, independent, and representative, not necessarily representative of the entire group, but representative of the group where you're trying to do the test. So let's say we want to figure out the ideal color for this button. We have find jobs in gray. We could have find jobs in blue. So if we wanted to determine which one was better, we could set up an A/B test. So we'd divide traffic into two groups. Group A we'd call the control, and they'd see the gray find jobs button, which would be the current behavior. And then group B would see the blue find jobs button. This would be the test. We'd analyze the metrics for both, and we determine which one was optimal. Now, just because we say it's an A/B test doesn't mean there's only two variants. We can test 5, 10, 41 different colors. It doesn't matter. We can also test multiple things at the same time. So in this slide, we're testing the text of the button label, find jobs versus search, as well as testing the color, gray versus blue. We test multiple things at once. This is multi-variate testing, and we do this a lot at Indeed. Currently, in fact, we're running, just in the past 30 days, 103 tests, 315 variations, and a lot of different combinations that any given user could see when they come to our website. And we're not just testing in job search either, resume, emails, contacts, job posting products. Basically, everywhere that you see Indeed, we're doing tests. Before I go in, let's give an example of an actual test we did on Indeed.com. This is the search results page. You're probably all familiar with it. And in the upper right corner, we have this box, get new jobs for this search by email. This is our job alerts product. It's one of the oldest products we've had at Indeed. Basically, job seeker can come in, type in their email address, and then every day we'll send them email alerts for the newest jobs for their search. Because it's one of the oldest products, for whatever reason, we didn't test it so much as far as the wording. And so we thought maybe there's some users who the wording is not quite clear to them. Maybe they don't understand the value of the product. And we could do some changes on wording and maybe explain to them more clearly. So set up a test. We have control, which was the current behavior, save alert. And then we come up with a bunch of different other behaviors we might want to test. So we'd go look at competitors' websites, similar features, just pick the best ideas we can come up with and try them out. What we do is we just divide users up. 10% would be for the control, and then 10% each for each of the different test groups. We'd run the test simultaneously across all of them and then see what happens. So our hypothesis would be obviously that one of these would do better, and would do better by increasing the number of job alert signups. Our chief UI designer believed that send me new jobs was probably going to win because it's the most clear and it's also just the biggest button, has the most screen real estate. So when we actually tested it, we were pretty surprised. Send me new jobs was number 2, but Activate was actually the best with a 12.8% increase in job alert signups. And not only that, every single group we tested outperformed the control. Like, we literally could have done anything and probably gotten better. And because, so this test was pretty complicated. We're testing 6 things at once. And because this is Indeed, we're also doing it in a bunch of different languages. So we didn't just test this in English. We did the same test across every language we're in, and different ones came out on top. As a result of these tests, over the past year, we sent 614 million additional emails. which is really impressive just by testing the buttons. So why A/B testing? Obviously, we got good results there, but why do we have to do it? First off, before and after testing is bad science. So if we're going to look at what's happening now, we make a change and see what happens later, we're not going to get results that are really valuable for us. The reason why weekly traffic isn't flat, it looks like this. And yearly traffic is even more pronounced, it looks like this. So let's say we're going to do a test at point A. We'll compare point A and do the test and then see what happens at point B. We're going to get a lot more traffic there just because of the seasonality, just because of the way visitor traffic goes. And with more traffic, we're going to get more signups. Likewise, we tried the same test at the end of the year. Point B is going to naturally get less signups than point A just because we're going to have less traffic there, completely independent of the test. And so it's going to be really hard for us to disentangle causation with correlation in this. So what do? We need to do real A/B testing. Eventually, we ended up with Proctor, which Matt will talk about in a little bit. But for now, I want to take you through what different methods we use for A/B testing at Indeed, how we got to where we are today, and our motivations for doing so. First thing we tried, multiple code versions, separate configurations per server, and then doing sampling by load balancer. To give you an idea of what this looked like, so we'd have one server running the old version of the code, that would be the control. We'd have another server running a new version of the code, that would be the test. And we'd have a load balancer splitting traffic between them. So this works. It's unbiased. We can do tests running at the same time against similar testing control groups and get scientifically valid answers out of it. But it's just a huge pain in the ass to QA, to deploy, not to mention rollbacks and failover. It takes way too many people, way too much time. And it's also not very flexible. Theoretically, we can test n different variations at once, where n is the number of servers we have. But given the overhead on doing this, in practice, we never did. So we needed something better. Finally, we ended up with libraries and custom code per test, which would allow us to arbitrarily group users, select groups, and implement different variations of test. This allowed us to run arbitrarily sophisticated tests. It allowed us to get unbiased independent control groups, and it allowed us to do it with fairly low operational overhead. We were deploying every week, and so whenever we did a deploy, we could put out a change to a test. It wasn't so bad. This shows the number of tests we were running per month during that time. Towards the end, we were having 35, 40 tests per month. We were making a lot of major improvements to all of our key metrics, and A/B testing had really become a way of life at Indeed. At that point, we were going to roll out a new product in early 2011, resume search. And we wanted to take all the great things we learned from these custom-coded tests and job search and expand them out to new products. Not just resume search, but anything else we might come out with. We wanted to keep the same power, flexibility, and speed of what we already had. But we wanted to see if we could improve upon it, make it even better. Our goals for a new system moving into new products would be increase engineering velocity. Being able to change tests with a simple code deploy is easy. Could we get it even easier than that? We wanted to standardize the representation so that all tests were recording the same things in the same way, which makes it really easy to build tools on top of. We also wanted it to work trivially across all of our products. If you attended Dan Heller's talk on engineering velocity, you may have seen that Indeed has a lot of different products. And we wanted to be able to have the tests work everywhere without having to do a lot of extra work. The solution we came up with to solve these goals was Proctor. Proctor is Indeed's Java framework for managing A/B tests and more. And we're happy to announce today that Proctor is an open source Java framework for managing A/B tests and more. And it's available on GitHub today. And to tell you more about how it works, how to use it yourself, Matt Schemmel.
All right, hi, how you doing? My name is Matt Schemmel. I'm a senior software engineer here at Indeed. I have been here for a little bit over 2 years now, and I am super excited to be standing up here tonight because in all that time, this is the first thing that we have taken open source. So super excited to talk about. Like Tom said, Proctor is an open source Java framework. It is written in the Java language. It can run on anything that runs on a VM. And now we're going to talk a little bit about how. First, we need to talk a little bit about the background and design behind how we set up Proctor, following which we'll discuss how to run A/B tests and then some of the more advanced features that Proctor supports. The background and design. Proctor is based on the lessons that we've learned over several years of running A/B tests in various ways. To run any A/B test with Proctor or without Proctor, you have to do a certain set of things. You need to define the experiment that you're going to run. You need to have a way to select from your visitors who belongs to which group in that test. You need to implement the change in behavior for the control group and the test group on your site. You need to log those results so you can analyze them later. Proctor attacks two of these problems. Proctor will help you to define the experiment, and it will help you to select the groups that each of your visitors should be involved in. Implementing the behavior, Proctor exposes the group, but how you implement them is entirely up to your site, obviously. And logging the results is too tied in to how you log your own results and how you do your analysis. So Proctor doesn't take any opinion on that. It just exposes the group membership and says, after that, do with it what you already do. We're going to use for our sample example here a very similar test. This will be the same job alert box, but because it's a whole lot easier to put into a presentation, we're going to change the color of the button instead of changing the text. To define the experiment, there are two pieces of information that we need. We need to define the buckets, just define which groups all your visitors will be split into, and we need to define the sample size that we're going to use. Our buckets are very simple. Control group, gray background. Test group, blue background. Our sample sizes, equally so, 50%, straight A/B test. Proctor divides responsibilities into the definition of the experiment and the application of that experiment in your code base. The definition lives in a bunch of files that live in a global pool of files outside of any particular product that is completely separate from all your existing projects. The application happens inside of each project as you apply those definitions to that product. And we'll talk about that in a little bit, but first let's define our experiment. The buckets just enumerate the variations. Every bucket is terribly simple. It has an identifier, that's what the code uses to recognize it, has a long description and a short name. That's for the people that need to refer to it. This maps very straightforwardly onto our toy example. We use 0 by convention as the control group and increasing numbers for each of the test groups. Here we just have 1. Description, control group, test group, and names gray and blue. Then we get on to sizing the buckets. How we get the right number of people into each of the test groups is one of the interesting aspects of Proctor. Selecting test buckets is extremely important because good science means you need to sample well. You need to be completely independent so that your tests aren't stepping on each other, and you need to be completely unbiased so that when you get results from the test run, you know that the results that you're seeing are because of the change that you made and not because of something else that accidentally slipped in. But this is also running a website, and so good user experience is extremely important as well. Selection has to be not just scientifically valid, it also needs to be blazingly fast and very consistent. We want to provide our users with a good, consistent experience. If we need to have equal-sized test groups, then the easiest thing we can do is just do a round-robin assignment. As people come in the door, you're 0, you're 1, you're 0, you're 1, you're 0, you're 1. That works, but that requires us to maintain global state somewhere to know what the next bucket to be assigned is going to be. Global state is bad. This will not be fast as we try and propagate that information around the world, and probably won't be consistent as that starts to get laggy. At a very small scale, if you have 50, 60, 100 people running inside of one of your tests, you might need round-robin assignment or something like that to ensure equal groups. At large scale, at web scales, randomized is plenty uniform. Randomized assignment at our scale is going to be independent and unbiased by the nature, but is it fast and is it consistent? That depends on how we do it. If we just roll the dice as needed, undoubtedly fast. Every time somebody hits the page where we show the button, we decide gray or blue. Completely inconsistent. As the same visitor is wandering through the site, they're going to get different results on every SERP. So maybe we roll it once and cache it in a cookie. Now that's a lot more consistent. Now it's consistent across a single domain or across a single device. But we need to decide how we're going to represent it. Do we want to have n cookies for all the tests or one cookie that lists all of them? N cookies, it gets hard to evolve. We have hundreds of cookies out in the wild that we need to deal with. One cookie compacts that. Now we just have one to deal with, but now we have a cookie we need to parse. And if we ever mess up how we write that cookie, we've completely invalidated all the tests that we're running. Worse yet, either way, the size scales with the number of experiments. If you have a site where you make a lot of tiny requests, if it's an Ajax-based site or it's a mobile site, and in any situation where you care a lot about the bandwidth, scaling that up can actually drastically affect you. So this will be not as fast as we want, not as consistent as we want. They're still independent and unbiased. We could cache in a session. Now we're only consistent for the length of the session. We're tied to one server or one data center if we're not externalizing the session. And a lot of our apps don't use sessions. We don't like sessions. Sessions make it harder to scale. Still, not as fast as we want, not consistent through time, not consistent across data centers, still independent, still unbiased. What if we roll it and cache in a database? We've seen something similar. Now we have that global state again. We've got to pass this around. Not fast, not as consistent as we want. We can do better than this. All the flaws that we've seen stem from the fact that we need to record the assignment, that we need to record which bucket we stuck you into. So what if we didn't do that? Instead of recording the assignment, we can recalculate it. If we assign every visitor to the site a unique ID, find a way to map that ID to one of our test buckets, then we store the ID instead of the assignments, then we only need to pass around one bit of information for every user. Is it fast, consistent, independent, unbiased? Again, it depends on how we do it. A very simple mapping. Say everybody has an account ID, and we just take the easiest possible approach, go mod n. Everybody with an even account ID, you're in the control group. You get the gray button. Everybody with an odd account ID, you're in the test group. You get the blue button. This doesn't even remotely work. Proctor is supposed to provide a uniform distribution, not assume that your IDs are already well distributed. You also have very limited bucket distributions. If I want 2 equal groups, 3 equal groups, 4 equal groups, fantastic, I'm in. If I want anything more complicated than that, no way to do it this way. So let's try a little bit more complicated approach. We'll take that same ID and we'll just divide by the range of ID, get a floating point between 0 and 1. Everybody less than 0.5, you're in the control group. Everybody greater than 0.5, you're in the test group. So this is better. Now our buckets can be any size because we can split that range up any way that we want to. If we want to run a 50-50 test, we're golden. If we want to run 25 and 25 and ignore the rest, we're still OK. There's a big problem with this, though. And that is now, if your ID scheme happens to be sequential, say auto increment, then the first half of all the users you ever see are going to be in your control group. The second half that you get up to will be in the test group, assuming you get there. This also is pretty easy to fix. What we don't want to do is to depend in any way, shape, or form on what ID scheme you're using. Everybody's already got some sort of ID scheme, and we want to be able to use whatever that is. So if we hash the ID before we map that to a bucket, and pluck an integer out of that hash. If we get a 32-bit number out of it, great. Otherwise, we just pluck 4 bytes out of it, and we say we're going to map that to the int range between negative maxint and positive maxint. Everybody less than 0, you're in the control group. Everybody greater than 0, you're in the test group. We've now kept our arbitrary bucket allocations. Great. And now, as we increment through our IDs, they've been hashed out to a completely uniform distribution among our buckets. Every one of our individuals is getting something that is unpredictable based on what their ID was. This works for a 50-50 split, a 33-33 split. Any split that we can break those inners into, we're going to get a good distribution across it. But is it independent? What if we wanted to run that same multivariate test that Tom described, where we test the text, sign up versus activate, while at the same time we're testing activate versus sign up? What we want at the end is to have 4 buckets of people where 25% of the users get a gray sign up, gray activate, blue sign up, blue activate. But every one of our inputs is consistent. The whole point of the ID is that it's consistent for that user. The hash isn't changing. Integers aren't changing. And so when we map all the people in the color test from their ID to a bucket, and we map that same ID to a bucket, they're going to overlap 100%. Instead of being split into fourths, we're going to split into halves, with 50% of the people being stuck in the control group for both, and 50% of the people being stuck in the test group for both tests. When we find out that the blue activate button is 12% better than the gray sign up, we'll have no way to figure out, was that the color Or was that the text? Or was it both? Fortunately, this is also easy to solve. As long as we can fix the lack of independence, so long as we include something from each test as part of our hash. If we add a salt to every test and use it as part of the function, then we've kept our arbitrary bucket allocations. We've kept our uniform distribution. And now we've got a complete mix-up. The same user hashed for 2 different tests will get 2 completely different distributions, and we'll get people in all 4 buckets split up the way that we want. Fixed. But is it fast? In a word, yes. The resume editor and the resume search products were the 2 products that we had that were first using Proctor. And on a arbitrary recent day, namely the one where I grabbed the screenshot, we were spending less than a millisecond per request allocating all the groups. But is it consistent? It's going to be every bit as consistent as however we store the ID. It's a deterministic function of that ID. And so we don't depend on any databases, we don't depend on the session, we don't depend on anything out there. However we choose to store that ID is the only bound for how consistent we are. Generally, we use a tracking cookie. They are easy to use. They're ubiquitous across the web. Every browser supports them. We don't need any server-side storage component to deal with them. They're automatically there. And they are absolutely the only thing that we can use the very first page where a user hits the site when we have no other information. These are mostly consistent. It is fast, independent, and mostly consistent because some people block cookies. They don't work across domains unless you do a big redirect chain. They're not going to work across devices ever. But we don't get a lot of traffic in any of those ways. Tracking cookies generally work for us. To do the mapping from a bucket to an ID range, it is just mapping each bucket that we have, our 0 and our 1, to a sub-range of the overall range. 50% of the people end up in the gray group. 50% of the people end up in the test group. Now, and finally, cookies are web only. So there are some contexts, if you have batch processes that run in the background overnight, anywhere where you don't have a cookie to keep hold of, sometimes we need something different. Fortunately, there are many different ways that we can identify a user. A tracking cookie is just one of them. If they've signed up to the site with an email address, we can use that. If they have an account ID with us, we can use that. If we did turn on sessions, or if you've turned on sessions, you can use that. If you have some sort of access token from an ID provider, you can use that. Proctor doesn't care what ID you use. It will use any ID that you can represent as a string, namely all of them. We use a lot of different ones. We use tracking cookies, account IDs, email addresses, all in various contexts. Generally speaking, we use tracking cookies. However, account IDs are great. That means that you're an authenticated user. When we use the account ID, we know that you're going to be consistent across domains if we're taking you across various domains. If you have a phone and a laptop and a desktop and a tablet, you're going to get the same experience across all of those. It's going to be consistent across your visit for as long as you're coming to the site. If we have an account ID, that's a great option to use. Email address. Sometimes we don't have an account, but we have an email address because they've just signed up for an alert. That is nearly as good as an account ID, and so we can fall back on that. Every test just picks one of these ID types. You choose whether you want to be split up based on the cookie, based up on account ID, based up on various things. Which one you want to use in any given situation is very much a matter of that test. If you are trying to optimize your registration flow, you're probably not going to use the account ID. Would recommend a cookie. There are lots of details about that. Now, how do we actually run this in Proctor? How do we make these definitions? The definitions are in a global pool, as I mentioned. Each definition is just a JSON file. It's very compact, simple, it's flexible. It is editable by humans. It's editable by machines. That means that we can both read it and write it with ease. The basic data is very straightforward. We have the description of the test, the salt that we needed to hash it, and the type. All of these are required. We have each of the buckets where we define the ID of the bucket. Again, 0 by convention is the control group. The name and the description, 1 for each of the buckets. The ranges where we map the bucket to its range. Again, for a 50-50 test, 0 gets 1/2, 1 gets 1/2. And that is the minimal complete test definition for Proctor. This is everything that you need to be able to run that A/B test, except for the code that runs that A/B test. So in order to run the A/B test, we're going to leave our global pool behind for a minute, and we're going to talk about the application. The application has a couple of things. It has the Proctor library, what we've open sourced today, and it has the test specification that you write that defines how your tests apply to that application. Proctor has a lot of modules to it. It's got the core modules, that is all the Java code that runs behind it. It has a couple of builders to integrate this into your build system, and it's got a code generation piece that we'll talk about in a minute. Along with the Proctor library, you get the test specification. This is just another JSON file. Instead of living in the global pool, the test specification is product specific, and it lives along with your product. It contains a list of all the tests that apply to this product. Not every product cares about every test. This specification just contains a list of references into that global pool saying which ones this product uses. Inside that, you list out what the buckets are. Gray was 0, blue was 1. And that is all the information that Proctor needs to be able to apply it. So in the code, to apply the experiment, we need to first select the groups. And to do that, on every request that comes in, we collect all the identifiers, and we then select the buckets for the opted-in tests. Somewhere in your code base, you have some code that looks something like this, where you're grabbing the tracking key and you're grabbing the account ID because you already needed those for your code. To integrate Proctor, you just put those into an identifiers, which is kind of like a wallet and just contains the value of each of those IDs for this request. Take that identifiers and pass it off to Proctor and say, please determine the buckets. You call Proctor one time to determine the buckets for every test. One time at the beginning of each request, and you will get the result for every test that you're running that application cares about. Once you have that Proctor result, you have all the information you need to render the response. To render response, all that we're doing differently for an A/B test is going to choose which behavior we want based on the bucket. So if I have a way to get the bucket, then in the code I can just say, if I'm in bucket 1, stuff this value in my model to render. Otherwise, stuff the gray value in the model to render. The Proctor result that we saw a couple of slides ago exposes those buckets. We got this by calling determine buckets on that set of identifiers. To get the selected bucket, you take that Proctor result, get all of the buckets, pluck out the test that you're interested in, and then get the value for that test. And right now, all the Python guys are saying, glad I don't write Java. Proctor result exposes the buckets, but very, very, very verbosely. We talked a second ago about the code generation piece of Proctor, and that is what makes this all a little bit easier to deal with. Those redundant names in the test spec, and I suspect some people in here were probably wondering, well, why did we tell it we were gray and blue? We already told it that once. We use those in order to generate a helper group. For instance, for the resume search project, we just called it resume search groups. That class, you feed it the Proctor result, and it just has a bunch of helper methods generated from your test specification that know about every test that runs. So you can just say, with auto-completable code, give me the test result, give me the bucket for this. Get the button BG color test value. Gives me the ID of the bucket for the button BG color test. There are additional helper methods that are just a Boolean for every bucket. Am I in the gray bucket? Am I in the blue bucket? This is obviously going to lead to much more clean code inside of Java. This is also very helpful for when you're writing front-end code. Because this is a Java bean, it is trivially easy to read this from Java server pages, Java server faces. If you use the templating technology like FreeMarker, Velocity, Closure, you can plug this straight into the data model. It can read the information out. It is trivial to serialize this as JSON, so you can pass it off to your front end. Every layer of your application now has immediate and simple access to your assignments. So, having rendered the response, we're now ready to log the action. To log the bucket assignments, Proctor's not going to help. Proctor just makes the selection and leaves it to you to log it however you're going to. When and how you log it is entirely up to the system that you already have. One obvious way is log it on a related event. When I show the page that has that button, log the result from that group. We take a different approach, which is to log every result on every event. And if you've been to some of our earlier tech talks, you've heard some interesting reasons why we think we're not always able to tell which events are really the relevant ones. So if you've seen them, you know exactly what I'm talking about. If not, check out the blog or come up and talk to me afterwards because they're a lot of fun. That is everything to do with the code. You don't need any more. So now we have the test definitions out in the global pool. We have modified the product in order to be able to use those test definitions. The only thing we need now is to get them both out to the world where users can see them. Our test definitions are maintained in our source control system, the same one that we use for our code. We use Subversion. You can use Git, Mercurial, doesn't matter. This gives us a lot of desirable features for free, such as history for every test, diffability, access control on a per test basis if we need it. When we're ready to roll new data, there is a publication step that takes the information from source control, publishes an artifact, and distributes that artifact around the world. Every application running out in the world on a tight loop is just reloading whatever artifact it has locally. This publication also happens via source control. We have two branches inside the source control. We've got the trunk, and we've got a production branch. Production isn't a branch in the sense that we're going to merge changes from trunk into production, but rather it's just a named branch. It's just a delivery mechanism where we pluck individual commits of individual tests and completely overwrite whatever that definition is on production and send it out to the world. Doing it this way gives us a few benefits. It's not the only way you could do it, but we get our same features for free. Now, instead of looking at trunk and seeing what the code thought it was, I can look at production and see when things actually changed in production. We get history, diffability, access control. We don't need to deal with merging for these relatively small files. And we have trivially easy rollback and roll forward just by picking a different commit from the history on the trunk. If we need to change the test specification, then that gets code generated, built into the product, and deployed out to the world using whatever the existing mechanism is. So we have these two paths that we can make changes down. Anything that changes just in the test definition rolls through publication and is live out in the world within minutes. Anything that changes the test specification uses whatever your existing deploy cycle is and gets out as quickly as you can do that. So that was it. That's all that we need to be able to run our gray versus blue A/B test on Proctor. There are a lot of additional features to Proctor that I'm going to walk you through real quick. First and foremost, the one we use all the time is test segmentation. Not every test is going to apply to every user. Sometimes you need to break things down by individual markets, individual languages, individual devices. Proctor supports the ability to segment any test through test rules. Every test definition in that global pool has 0 or 1 rules. If it has a rule, that rule is just a Boolean expression. If the expression passes, returns true, then that user is assigned a value for that test, assigned a bucket for that test. If the expression returns false, they're not. They're ignored for the purpose of that test. The rules are written inside the unified expression language. We like EL because simple things are simple. This rule is part of the test definition back in the global pool, meaning that we can change this rule at any time and have it change live worldwide within minutes. If we have a fairly simple rule, like this only applies to Canadian users, country equals CA, yes or no? We can do a little more complicated things. EL supports primitive and rich data types. So we have a user agent object and have actually open sourced the user agent object that has a lot of simple things to help us identify phones, tablets, some of the capabilities of various devices. And so if we need to split up a test based on device identity, only phones or tablets, easy. By device capability, this test uses HTML5. Do you support HTML5, or should I ignore you completely? If this test needs geolocation or the ability to upload a file, I can narrow down the people who are considered for inclusion in the test right up front. EL is easily extended. There are a set of standard functions that come with JSTL. So if I wanted to limit this test to only Indeed employees, I can check the email address. If I need to limit a test to only a few countries, I can write an extension function to see, is this value in this list? And finally, EL does support arbitrary complexity. While the simple things are simple, it's nice when we have something that's a little bit gross, like, is this Andrew 2.1 or above, that we have the ability to specify that. So what context is available? So far we've seen country, language, user agent, account. What is a full list of things that Proctor is going to allow us to look at? Proctor doesn't give us anything. The context is defined inside the same test specification. This is a contract between your code and Proctor to provide these values to Proctor when you call it. Just like I declared the list of tests that this product cares about, I also declare which context variables this application is going to provide. I'm going to give you the country, the language, and the user agent. And now, when I make this call to determine the buckets, instead of passing just the identifiers, the generated code, which was generated from that test specification, requires that I pass each of these values as well, meaning every request is going to get these values. Every test can depend on these values. Next, payloads. Just a minute ago, this code popped up on the screen. I didn't actually see anybody cringe, which I respect you for. But if anybody wasn't thinking, why on earth do I need to do a new code deployment in order to change the shade of blue on the site? Some tests don't change behavior. They just vary data. CSS color tests, changing the display text, changing the weights in one of the algorithms on the back end. Proctor supports this kind of test without a code deploy through payloads. A payload is just a value that's added to every bucket on a test. And Proctor verifies that for a test, either every bucket has a payload or none does. If we're taking our same test, gray versus blue, the payload is pretty clear. Just include the CSS color value that we want to use. That payload is included as part of the test definition. My payload is a string value of gray. And because that's in the test definitions in the global pool, I can publish it, and that change is live on the site within minutes if I want to change that from gray to white to whatever it is that I'm testing. It is declared in the project specification, but which means just the type, not the values that it can take. So my project knows this test is going to have a payload with a string value attached to it. Reason that I want to have this? Primary use of the test specification is to generate the code. Now my generated class has an additional method that lets me pluck the payload value for whatever the active test is. So instead of having to say, am I in bucket 1, use this string value, otherwise use this string value, I can just say canonically, use whatever string value is in the active bucket for this test. Cross-product tests. We have a lot of products at Indeed. If you saw Dan Heller's engineering talk, he talked about how we break some of our bigger products out over time. These cross-product tests often need to run tests across them. And there are a lot of different flavors of this. You can have two pure web apps that both need to do part of the same test. You can have a client web app that needs to work with a service to implement a test. You can have two flavors of your mobile app, the native version and the web version. You would like those to be the same. Just as there are many different ways to do this, there are equally many ways to coordinate those tests. You can have tracking parameters on every link between them. You can put a parameter on your service request. You can just let the service give it back in the service response. Say, I was in this group. You can not let the service know about it at all and just say, I'm going to make different service calls depending on which group I'm in. These are all great. They all work, and we have used all of them. They all have one problem, which is that they require code to change on both sides of that. Quite a lot of the time, when two products need to know about a test, it's because it changes one product, but we just want to see what happens in the other product. There's no code changing over there. There's no behavior changing over there. When that happens, Proctor gives us an interesting alternative. Because we're using a deterministic function of the ID to calculate which bucket we go into, as long as both the products use the same identifier and pass the same context variables, that function is going to result in the same assignment. So two products can share the same test assignments without any coordination whatsoever, other than I'm in this test. Evolving tests. Tests are not static over time. Do you remember the animation that was up on the front of the screen up here? As everybody walked in, we had a lot of different colors going back and forth. That was showing a few of our tests and the history of that test as we split them up. These are not turn them on once and forget about them. Our 50-50 A/B test is not very realistic. Given the amount of traffic that we have, most of our tests are 1%, 5%, 10%. And so what happens once we have this out there for a while as a 10-10 test, and then say, okay, it's looking good. Everything's standing up okay, everything's behaving properly. I want to let more people in and see how it works there. I'm going to slowly roll this out. If we do the naive change to roll this up to a 50-50 test, we've taken the set of users who used to be in the test group, and push them back into the control group, because the first half of that range is now control. So these folks here in red had the original behavior, got moved to the test behavior, got moved back to the control behavior. If we roll it all out, we'll be back in the new behavior. This is pretty trivial for a gray versus blue test, but if your test were, do I need to log in to use your site? You can see how moving back and forth between groups is pretty problematic. So Proctor gives us the ability, because we completely control that range, to evolve our tests smoothly over time. We talked, when we have a 10% test, but we said that all the ranges always need to add up to 1. We're missing a range here. A 10-10 test isn't really a 10-10 test. It's a 10-10-80 test. 80% of our users are just in a bucket called inactive, that we call inactive. Now, since we have this bucket available to us, and since we control that range, instead of reassigning people from where they were originally, we can just make it a 10-10-40-40 test and make sure that all of the new assignments come from what was originally just the inactive bucket. Or, since when we rolled out the 10-10 test in the first place, we knew that this is what was probably going to happen, we can arrange things a little bit differently. Sometimes we don't want to evolve tests smoothly. Sometimes we want to evolve them as turbulently as possible. If we run a 50-50 test for a while, and we get unbelievably good, or maybe unbelievably bad results, and we can't bring ourselves to believe that these results are due to that test, since we use an arbitrary salt as part of the test, at any time we want, we can change the salt, thereby shaking the table and completely changing how people get assigned into groups. Contextual sampling. Sometimes it's not enough to say that I want a 10-10 test. How big these groups are is based on a lot of things. How confident we are in the product, how long it's going to take us to get this test to significance. And our traffic varies wildly, not just through the year, as Tom mentioned, but around the world. Maybe we want to run a test that is going to come to fruition within, say, 2 weeks. And 10% of US traffic will get us there. But maybe we would need 20% of the traffic we get in Canada, or 50% of the traffic we get in Asia. Proctor gives us the ability to have more than one allocation for every test that's running. Every test definition doesn't have just one set of ranges. It has n set of ranges, at least one. Each allocation is just a rule and a set of ranges. The rule decides whether or not that allocation applies, and the ranges are just 10, 80, 10. The last rule, there must always be one rule. The last allocation must always have no rule. That is the default allocation to which everybody will fall into. Allocation rules use unified EL, the same as the test rules. The same context variables that we use to decide whether the test applied are used to decide which allocation applies. And it just runs down the list and picks the first matching allocation. So if we wanted to have a test that ran just inside the US, we could set this up in the test definition by giving it one allocation with a rule that checks the country, and a second allocation that's the behavior for everybody else. Again, this is a part of the test definition, meaning it's in the global pool of test definitions and deploys without needing a code deployment. We can change these on the fly within minutes. And lastly, pre-production. We've been pretending tonight that we make a bunch of changes to our tests, push a button, and everything's magically out in production, which is not really the way things work. We have a few environments that things roll through, starting from local development, where we write the test in the first place, through an integration environment, QA environment, production environment. Just as with our source code, every commit to the source control changes the integration environment. When we decide it's ready to go to QA, we push that commit to a QA branch similar to the production branch. When we're happy with it there, we push that commit to the production branch. We have a set of tools that we use as well. So I don't know if this was clear, but we have two paths that changes can flow down. They come out the publication path from the definitions and the deployment path from the specifications. The very first time that the definitions and the specifications know anything about each other is inside of a running application. And so the show test matrix is just a debug page available as part of the Proctor library that will show you the current test matrix, which tests this application knows about, what the state of those tests is, which buckets they have, et cetera, et cetera. This is the very first time that we have pulled together and verified these two pieces of information. We can also very easily show which groups am I in. Sometimes during QA or even during production, it's important to know which test group am I in right now so that I can explain what I'm seeing on the site. And finally, privileged users can force an assignment. So however you identify privileged users to your site, you can give them the ability to force their way into a group. So if I am navigating to the search results page and I want to see the effect on this page of being in a particular test group, I can force myself into test 1. And that page will then render. It'll force me into that bucket and render. This assignment can be run by any privileged user, can be run by any page, and will be cookied to the rest. It'll be given a session cookie, so that then the rest of your session will have that same consistent experience. This is fantastic for QAing both a control group and a test group. If you need to write automated tests, they work the same way. That does it for the implementation of Proctor. And so now I'm going to turn you back over to Tom to talk a little bit about some things that we do besides A/B testing.
All right, so the title of the talk was Proctor, A/B testing, and more. So now we get to the and more part. We started off using Proctor just to handle our tests, but we realized it could be a really valuable tool for managing behavior as well. The first thing we thought of, kill switch. So whenever we have a new feature, we expect everything's going to be working, but just in case, we can wrap it in a Proctor test, set it live at 100%, and leave it there. On the off chance that we need to somehow disable this feature, we can turn it off with a simple data push, have the feature be deactivated in minutes. Don't need to do anything like deploys, rollback code, etc. Going on from there, phase rollouts. Let's say we have an experimental feature, and we don't know what the impact it's going to be on our infrastructure is. So we can deploy it to production and leave the active bucket at 0%. We can then push data to change it to a 1% test, monitor results, increase it to 5%, 10%, 20%, up to 100% as soon as we're ready for it. We can also use it as a throttle. Sometimes we have tests that are running or behaviors that are running all the time, but we don't want it to be seen by every single person. For example, if we're doing some trace logging, if we're presenting surveys to users, we don't want to ever turn this off. We don't want to ever show this to everyone, but we might want to have it just at 1%, 5%. So we can basically use Proctor allocations to increase it and decrease it based on our needs. We also use it as a feature toggle. As Matt was saying, sometimes a test only applies to certain types of users. Only mobile phones, only users in Asia, only people who are logged in or who have a resume. We can have these features in production wrapped in a Proctor test with multiple allocations, and we can turn it on in the places where it's valuable and leave it off in the places it's not. If at some point another country or another type of user becomes eligible, we can easily turn it on for that group of users with a simple data push. And finally, dark deploys. This is something that Dan Heller talked about a little bit in his talk on engineering velocity. Sometimes we're working on very big projects that we're not going to be able to have everything ready all at once, but we still want to be able to see it in production and QA it ourselves. So we'll turn this on, deploy it in production, but leave the active bucket at 0%. Then QA people can opt themselves into the group, look at the behavior, make sure it's working correctly. Another use case for this is if we have a feature that we want to get out into this week's deploy, we're not quite done QA testing it yet, we want a little bit more time to check it out, so we can push the deploy, leave the feature on at 0%, and then at such point that it passes QA checks, we can turn it on. Another thing we use it for, cross-product coordination. Sometimes we have dependencies between products. For example, we wanted to release a new resume wizard on our resume product, and we wanted to have a promo pointing to it from our job search page. So we deploy the code with buckets in both places at 0%. Then we can turn the resume wizard up to 100%. Once we're sure it's there, we can turn the homepage promo up to 100%, and everything just works. So it makes it a lot easier for us to deal with complicated dependencies without having to do some sort of crazy deploy dance around it. I showed this graph earlier. This is the number of Proctor tests we're running, or the number of tests we're running simultaneously per month. And around March of 2012, we were running 35, 36 tests a month. And then in April of 2012, we released Proctor and started using it for more tests. And this is what happened. Today, just in the past month, we're running 103 active A/B tests across all our products. And additionally, we have 65 different feature toggles in place, more or less permanently on features that we've tested initially in a Proctor context. Additionally, as we use Proctor, we found that Proctor made it really, really easy to manage our tests, but there's still a little bit of overhead in terms of how do we manage the process around it. Indeed, we use Jira as our issue tracking software. Probably some of you people use it or something similar. And we need to track every test, every change to every test, and make it all in one place where it's easy to see. And we found that this was more cumbersome than it needed to be for us. So we built Proctor Webapp. This is intending to be open source soon, and let me walk you through some of it. Basically, we can see for every test, what are the test buckets, what are the allocations, what are the behaviors. We can also then make simple adjustments to bucket sizes. And just like Matt said, we can take arbitrary commits, we can cherry pick them and push them to production. And Proctor Webapp helps us manage the Jira interactions of that. It'll move things through the Jira process, make comments, etc. We're planning on having this open sourced, and so even if you're not using Jira or Subversion, you can implement your own hooks and use it in your own environment. Additionally, Proctor enabled us to add a lot of things onto some of the tools we already had. So the next tool I'm going to show you, it's not open source, but it's a tool we built inside called Test Stats. We were running so many tests, we needed some big dashboard where we could see all the tests and see how it affected all of them. So we'd have a list of all the tests, when they started running, and then all the changes for all the metrics that we care about. It's actually a lot more metrics that we track now, but this is a little older screenshot. So before we had Proctor, looking at this, we have a lot of test buckets. What are they? If the test buckets change, if the payloads change, what do we do? By hooking this into Proctor, we can now see what are actually the behaviors for all these test groups. It's not just group 6, it's label save. We can also see what was the history for these groups. That test that we showed at the very beginning, so we initially tried it in the US, then we rolled it out to all countries. We decided the US and turned it off there. Then we turned it off everywhere but the Netherlands, tried some more variations, and then finally arrived at a solution and rolled it out to all the countries. And having this history in our tool made it a lot easier to understand what exactly was going on. So we've talked a lot about Proctor and how quick it is, so figured it would be good to do a live demo and show it off. So if you guys can get out your phones and tablets, Jack will walk us through Proctor Live.
I'm really excited to get to do a demo. You've seen some code and heard about how Proctor works and how you can use Proctor. And now we're actually going to get to all experience a Proctor test together. Everyone in this room is going to get to experience a Proctor test. So I want you all to pull out your smartphone or your tablet or your laptop if you've got it in front of you, whatever you have, and go to this URL, go.indeed.com/demo. And while you're doing that, I'm going to tell you a little bit about what you're seeing. This is a simple web app. It is a simple Java web app hosted on Heroku, and hopefully a single Heroku instance can handle all of you people hitting it. We're finding out right now. And it's going to run a background color test. So we're basically which bucket you get assigned to will determine what the background color you're seeing is. In the initial allocation, it's going to be half of the room should be seeing just the control, the white background. A quarter of the room should see orange, and a quarter of the room should see blue. So right now, I'd like everybody to point their devices towards the front of the room. I see pretty much half white, yeah, about a quarter blue and a quarter orange, so that looks like it's working. That's great, so let's look at how that's set up. So the way this actually works is it's loading the test definition from a JSON file that's in a gist on GitHub. And this is the gist right here, so I've got it blown up so everybody can read it. We're going to scroll down and take a look at how it's set up. So it's the BG color test, the background color test. You see all the stuff that Matt was showing you before, assault. We start with an inactive bucket, and notice that there's a payload there. And as we look through, we've got a few different buckets, 0, 1, 2, 3. And they've got names, all color 1 through all color 4, and they've all got payloads that have a actual color value associated with them. So if we scroll further down, we're going to find our allocations. We've got one allocation, and it's saying that 25% are in group 0, 50% in -1, the inactive, and 25% in bucket 2. So that's bucket 0 is orange, I think, and bucket 2 is blue. So that is how simple it is. And now we're going to do the really fun thing of editing this live, which only makes me terrified. Thank you. So the most fun part about this is editing it at this size. So we're going to go down to our allocations. We're just going to say bucket 0, you're now 50%. -1 inactive, you don't get anybody anymore. And bucket 2, you're 50%. And we're going to update the gist. Now, everybody, please point your devices back to the front of the room. And we should see everybody blue and orange. And I don't know if you can tell that on the screen up here, but everybody is either blue and orange. I don't see a single white out there. So that is really exciting. Now, but wait, there's more. We're actually, let's say, so there we are, 50-50. Through extensive of study, we've decided that blue is the best because blue is my favorite color, and that's good science. So we're going to go in here and grab, we're just going to copy paste a whole spec instead of making you watch me edit, but I'll just go down here and show you that in fact there's a single range here with 100% at bucket 2. So I'm just going to grab this. I'm going to come over and throw it into my gist. Please point your devices to the front of the room. Everybody should be blue within 5 seconds. Yep, everybody's blue. Awesome. Okay, now that was fun. And now let's do something wacky. Let's forget about the sort of percentage allocations and just use Proctor to do something contextual, which is we're going to use the user agent on all of your devices. And we're going to split it up into the 4 colors that we have defined with our payloads. We're going to say there's one, orange is going to be for Android and blue for iOS, but actually we're going to say magenta is for newer Android since Ice Cream Sandwich version 4.0, and green for iOS 7. I imagine we're going to see more green than blue actually, but we'll see. This is my own personal little test. And so we're going to go grab another, okay, 1 second. Let's see here, we're going to grab another one. So this one, I just want to show you, there's nothing tricky happening. What we're seeing here is a set of allocations, and each allocation has a rule. The first rule here is if it's Android and the major version greater than or equal to 4, we're going to go into bucket 1. The next rule says bucket 0 for Android otherwise. Bucket 3 for iOS 7 or greater, and bucket 2 for iOS otherwise, and finally the fallback rule, which will go into the inactive group. So if any of you have been doing this with a non-Android, non-iOS device, you're going to get white. So we're going to see some white this time. So let me grab this. Yes, and yes, the Windows Phone folks out there, we're sorry to discriminate against you, but. So I've copied and pasted that into my gist. If everybody can point their devices to the front of the room. I see quite a bit of Ice Cream Sandwich or better magenta. I see some blue iOS. You're holding out. You don't want iOS 7? What's up? And some iOS 7. So that is the demo. Thank you for your patience there through going through that. This demo is also a reference implementation for Proctor. It's running on Heroku, as I said. You can feel free to clone it from the Heroku site if you want to run your own version there. You can read the source for it on GitHub in our Proctor demo project under Indeed Eng. And so check that out. It's a good way to get familiar with Proctor if you want to give it a spin. Thanks.